Agricultural IoT, and the main purpose of this one is to detect any disease in the crop and all. So we have purchased a camera. So this is the camera which is using it, and we planned it to put it to the drone, and the drone will be going around the field and it will take pictures. And pictures using a tiny ML, which actually tries to identify the diseases and classify them. Okay, next line. So early detection of crop disease is critical for effective treatment, because once the disease spreads over the complete plant, then the plant has to die. So before that only, early detection, we are trying to look into that and see that the detection, what we are trying to do, matches with the manual detection. Once there is a detection, manually some scientist will go there and see whether it is matched or not, because we are in the testing phase. So once it is been stabilized, then we can give it as a product. So this is actually, we are trying to compare with the professional and the model what we have developed, and we'll do it for at least 6 to 8 months and see whether the outcomes are matching or not. So once it's stabilized, then we will do the technological transfer of that. And this is mostly, we are in contact with Indian Agriculture Research Institute, IARI we call it as, in Hyderabad. And they are doing on these plant disease detection and so on. So what we try to do is, we have 3 layers in our implementation, convolutional and the pooling area, and then we are trying to use the outer output layer, or fully connected layer we call it as, for predicting the diseases. So next. So this is an example of it. What we are trying to take is, you have an input image, we take some portion of that image and trying to give them weights. Actually this is 1 bit, like you are only doing 0 or 1 transformation in a 1 bit LLM. It is not the complete blown LLM, because the complete LLM database cannot sit on a small Arduino kit and all. So we want to see that as minimum as possible, we want to reduce it so that it can sit in the Arduino board, and we can put that board on the drone so that it can go around. So the limitations are that traditional CNN leads to high computational cost. It needs a very high processor and RAM and so on, memory and all. And we are trying to store that image right now we are trying to put it in the hard disk and we are trying to manage the issue, but actually we don't want such type of arrangement in our system. We want only a lightweight, a small data set only. So we are using the binary set for that 0 and 1 representation weights. Next. Next, this is what we are trying to do. We are using the binary representation of weights and activation. We are not using the complete floating arithmetic for the representation and all. And that reduces the heavy utility and computational cost on the hardware and the mathematics on the software side. So this is 1 bit LLM. We are trying to reduce the floating point arithmetic into a binary arithmetic, and then we are trying to do it. By doing that, what we are gaining is, we are only doing additions, not multiplication. Whereas here we are trying to do both multiplication and then addition. So we can see that the computationally how much we have reduced it, so that a small hardware can sit there and do the job for that. So this is the improvement what we are getting it. So you can see that the floating point arithmetic has been moved to binary arithmetic, and it is only a binary representation we are trying to use it. So previous slide. So you can see the reduction in the cost. The hardware cost has been minimized drastically, so that we can give it to the farmers in an affordable price. We don't want him to invest heavily on the product. We want that the product should be around, our aim is to see that it is not more than 2,000 rupees, so that everybody can buy it. It is not that we can put it to 8,000, 9,000, 10,000, and the market will be very less. So the main job over here is a cost-effective solution and accurate solution. So based on this, we are trying the 1 bit LLM, and we are not achieve the complete efficiency. We are still looking at other alternatives, and we might move to 2-bit LLMs also. The next. So this is how we have implemented. We have selected the data, quantized the data set to 1-bit using suitable methods, model trainings, specialized training methods like binary neural networks. Instead of traditional CNNs and so on, we are only trying to look at BNNs. And we employed some optimization methods to do improve the performance. And we have tested it, but we are still in the testing phase only. So this is the bit LN, and this is your LLM model. And you can see the energy consumed is very less compared to your bit N network rather than your traditional LLMs. And even if we increase the size also, the power consumption is increasing. But we are trying to see, because the size, if you try to see, they are very small in bytes only. They have not improved into kilobits also. So once you are moving up higher, the energy might be costlier. But we don't want to do a continuous monitoring. We want to do a pulse type of monitoring where whenever it is required, we put it on and see. Because what happens in agriculture field is, the disease, when it is affected, it affects only an area, it will not spread out. So slowly it tries to spread out. So if you monitor a specific region, it is sufficient to know whether the disease has started or not. And that's the main aim of it. So the challenge is data loss. This is primarily, we are not capturing everything. We are truncating some of the data. So we might be losing some information. But still, we are trying to see what are the best methods to filter it out. And the accuracy is the prime important. Right now, we are only going up to 60 to 70%. We are not reaching 90%. And applications is only a limited one. Like specifically, if you are trying to see that in this area, this type of disease is predominant, we can use that data set only, instead of scanning all the data sets for different diseases. Because even when we talk to the researchers in the agriculture field, they told that there are specific diseases which will be occurring to the rice plants. It's not that all the diseases will be affecting the rice plant. So we want to limit the data sets to those specific applications and see how it performs. Yeah. So this is another important thing. We can extend the model to other applications also, like speech recognition, image classification, neural language processing, NLPs, and so on. If we know that there is a specific problem with the speech, we can use this to enhance that also. It's not the complete speech we are trying to do. We are only selectively picking up some notes and we are trying to train it. Even image classification also, this is another prime area where people are trying to do, because the doctors want to know specific area only what is the effect instead of scanning the complete body. So when you are trying to look at a specific area, processing of that image in that size, LLM will do very good, 1-bit LLMs. The next one. So this is what we are trying to anticipate, like 1-bit LLMs are very good for IoT applications, because we are only, the sensors are specifically looking at one job at a time. Like temperature sensor only look for temperature. Like pressure will only look for pressure, or humidity only look for humidity. So if we can target a specific data set, not the complete data sets which are there in the Kaggle and all, you can definitely see that 1-bit LLMs gives you good performance. So that's the information what we have derived, and we are trying to look deeper into that. And and you can see that this is very good at edge only. You need not have to transfer the data somewhere else. You can compute there itself. On the drone itself, you can compute it and send it to your mobile. You can see the details on that. So this is another thing. And before that, we want to add a few more things, like we are planning for a local server monitoring station, which automatically when the drone is flying, it tries to record and send the SMS to that client directly. It is not that we have to push it to cloud and all. For that, we are trying for LoRa connectivity and all, which we have not succeeded yet, but I think we will do it within short time. And the advantage with LoRa is, even if the field is far away by 1 kilometer, 2 kilometers, we can easily cover it. Because the range is up to 10 kilometers, we can cover it. And we are using the small camera ESP32 cam, which is around 800 rupees. And we are putting it on the drone and see how it performs. But right now we have a lab model only. We have the camera connected to the Arduino, which we are trying to process it. Okay, next. So this is the workflow what we are trying to do. We capture the image. First we try to capture the image. And then we try to label the data in Edge Impulse. And that is the software platform which we are trying to use, Edge Impulse. And we are trying to create some impulses with the image size. And then we are trying to generate the image features for further processing. And we are using some selective ML routines for training the data. And then we are trying to find it out, use the Arduino and try to capture the images for testing. Right. So here in data processing, we are labeling, considering for healthy plant and a diseased plant. And another thing what we are trying to do is, it's not when the disease is there, the growth or the height of the plant also varies. So we are trying to look in that front also, rather than directly looking at disease. Whenever there is a substantial difference in the growth of the plant, we want to see whether it has been affected by disease or not. So first level, what we are trying to do is we are scanning the health of the plant, and based on that, we are taking a decision whether the plant has a disease or not. And then we are going into the lower details. We are not doing all at a time. So these image data, what we are collecting, we are trying to push it to upload into data acquisition and train the model. And then with the impulse is created for configuring the model, and image processing block and learning block are added for classification. And the standard image size is 96 by 96. And after configuration, image features are generated for model training. So this is the model training flowchart, or algorithm you can say, for detecting the leaf disease. So the first one is input layer, and then we have 2D convolution, we call it as pool layer, and then we have another pool layer, and then flattening layer, dropout, dense layer, then dropout, and you can add the layers so on, and finally you can get an output layer with 4 classes. So what we are trying to do is, from the huge data set what is available, we are reducing, we are picking up what is required, and we are removing the other one. So once you have a very small data set for testing purpose, we only test that one. So we are using CNN, we are using CNN algorithm to detect that, and this is a standard algorithm which we have seen convolutional neural networks. So now we have successfully trained and optimized the Edge Impulse, in Edge Impulse, and we have a format compatible with the ESP32 CAM also. And this is, we are directly integrating with the Arduino IDE environment, and in the Arduino sketch only we are trying to deploy it. We are not trying to use a high-end process or a high-end software over here, only the simple routines we have used it. Next. Yeah, now we will have a look at what we have done up till now. Figures చూపించండి first. So these are the various figures which we have captured it. Yeah, next. Yeah. So the next one is there. Okay, the disease part expanded. Previous one. Yeah. So you can see the disease part, the brown parts are all disease infected. The green one is healthy one, but you can see that there is specifically some disease in the brown sections. The leaf is turned brown. So this we are trying to capture it. Previous. Yeah. So the brown ones are the disease affected and the green ones are healthy. But we want to know, basically first one we'll see based on height, and then we go into deeper. Whenever there is a growth difference, then we go specifically over there and we try to capture these pictures, and then we give it to the neural network to predict the outcome. The next one. So this is standard one. You can see that most of the plant is healthy rather than affected. And the basic thing, if you try to see, there is a difference between the affected leaf and the old leaf. The old leaf also turns brown, right? So whenever there is a mixture of green and brown, we try to concentrate more over there rather than completely brown. Yeah, next. So this is again a affected leaf only. Partially one side is green and one side is brown. So next you run the code. So this is the code which we have written for training and validating and so on. Yeah, run. So this is the outcomes what we got when we run it. So the model requires only 1.62 MB of RAM. So you can see that the Arduino board, if you try to take, this is too heavy for that, right? Because the picture size is the size 96 by 96 only, but this is running on a complete CNN. When we go to 1-bit, yeah, here you can see that the total parameters, the model size is only all are kilobits only. Only the number of the middle layers what you are trying to see, we have increased it to see whether it can improve the performance and all. But the management of memory is kilobits only, which Arduino board can take it. Right? This is what we have noticed it, but it has to be tested rigorously before a product is being made. So the memory is only 180, 138K. Right, which can sit reside happily on the Arduino board or ESP32 board. And you can see the drastic difference from 1 MB to 138 kilobits. It's a huge saving on that. But still, we cannot claim that as a outcome because we have not tested to the 100% efficiency. We are getting only a lower efficiency, but still we are able to detect the disease and identify them. So is there any table? No, these are accuracies are okay. Diseases, what are the type of diseases? You don't have that, okay. So this is about the product, what she is developing it. And I think by 1 or 2 months, it can be come to a final stage. So any questions, I can answer them. No, we are trying to filter out the unnecessary bits and take only the specific bits what are required, and we are trying to do it. So we have filtering sections too many in our program to remove. Yeah, mapping it. The problem is each pixel has a floating point arithmetic. So we are not taking that. We are only representing 0 binary values, having a threshold value. If this is that, you go to this, otherwise come to this. The threshold value is there. It is not that threshold value is, you can keep anything, but we kept it at 0.5 because we know that green or brown it can be. So you take a picture area and see whether it is green or brown. So if this is that, you take 1, otherwise 0. That's the first level of doing it. So afterwards, we can tune it, fine tune it to get better results, but it takes some time before we make a decision. Because we are collaborating with the researchers at IARA, and I think they are expected on 18th over here, Saturday, next Saturday. So once they come, we get more information about it. So this is mostly, there are 2 sets available for us on the internet. One is Kaggle site, and the other one is Indian Institute of Rice, IARA, Indian Agriculture Research Institute. They have their own data sets. They are not open source. They only give us for project purpose. Right? And we, It is not open source. IARA is not open. Kaggle is open source. Kaggle is open source. But the problem over there is the Kaggle side doesn't have too much of rice data. They have wheat and pulses and all these things. They have rice data, but that is, if you try to compare that, they collect the data sets from all over the world. So you can see that there is Thailand, Philippines, and all these people are rich product rice they produce maximum. So their data sets also comes in. And the disease might vary from country to country also. Sorry? Yeah. So we are filtering based on, you want to add something? Threshold values only. We are not fixing anything else right now because we are waiting for the response from the agriculture people. So once we get it, then we can say authentically we are doing like this. Right now we are only filtering it out by, like there might be short leaf and long leaf. So short leaf you eliminate, long leaf you keep it. And the plant height, some are like 2.5 feet, some are 3 feet, and also we restrict it to some height. So you based on some Indian standards, we are trying to fix it up. And it doesn't mean that the Kaggle site can supply those things. But IARA people have a very good data sets. They are not giving it out, but they are giving small sets to test it. Binary only. We are only doing binary classification for 1-bit LLMs. The other CNN also, full-fledged CNN also is there with us. There the efficiency is more. చూపించండి. Where it is? You are showing? Here. The accuracy is 96%. Yeah, we are doing that only. Quantizations only we are doing it. But we don't have the freedom to do that because the... in the back propagation, we are reducing the scaling of the... No, that thing is right, but the code itself will not sit on Arduino. Right? We wanted it to be in kilobytes. Right? Whatever we do, we want to bring it to kilobytes so that we can use the professional 800K and 800 camera and see that the price is only 2,000 rupees. Because every farmer should afford for it. It is not that only 2 people or 3 people can afford. Because I think he knows well, when a startup comes, we only see the marketing side rather than the product side. If I make 2,000 product, there can be 100 people who can buy it. If I make 20,000, only 2 people will buy it. Right? That's the main aim. Otherwise, we can, standard CNN, we have done it. It is coming up to 96, 97% accuracy and all. And it is established that your predictions are good. But our aim is to see that it is as low as possible, bring it to standard, so that Arduino doesn't cost as much. Or if I go to some other hardware like NVIDIA or Black Box or Sony or something like that, the hardware itself will be around 4,000 to 5,000. Drone is, now we have very low cost drones available. Where is drone out తీసుకొస్తారండి? We have a small lightweight drone which can fly and get back. Drone is around 1,800 or 1,200. It's not that costly nowadays. Right? Or you see, we are also planning for a small box like mobile phone, where the farmer can show like this and he can get what are the values also. That also we are planning it. It's not that we are not planning for it. No, there are people who can buy this much, and this much. So when you develop a product, you plan everything in a go. I will not do multiple times, right? So we have a handheld device to which this camera and Arduino will sit in it. He can just scan it like this and he can get the values on his mobile. And at the same time, there might be people who are having large fields. He cannot go around all the things. He can use a drone to complete it. Right? So we have both the things in our mind. It is not that only one thing we are planning for it. చేయాలని చేయలేదు. Because she is still in testing stage only. It is not that it is completely, because it's like, there are two things over here. One is it has to be certified by some organization for your product to be validated, right? So we are heavily depending on ARA, and why I am depending is my brother is working there. That is the other story of it. So he's trying to help me out in the data sets and all. No, these are ours only. These pictures we have taken it. From mobile we have clicked some photographs and we are testing it. And the Manikanda who has left, he has fields, right? Agriculture fields. So whenever he goes home, we will ask him to get some pictures. And even if you give some images, we can process and give you back. I need sponsor for that. Right? The problem is sponsoring. If the wheat people sponsor me, I can extend my thing to wheat. If some vegetable people will sponsor me, I'll. But finally, if the product is there, adding the data set is not difficult. Right? I can replace the software every time. If somebody says I want it for rice, I'll load the rice data set and give. So this is the drone which is there, which will fly, taking the camera around. No need, it's okay. This is the controller which you have, you can control it, and this will go around and pick it up and come. Okay. This is only 1 kilometer. Not even one, less than one, but height it can go up to 1. Height 1 kilometer it can go. Horizontally it is only up to 500 meters or 600 meters. Yeah. No, it should not have obstacle. The antennas should communicate to each other. That's why it's like height it can go, but horizontally the obstacles are there, so it will not be that easy for us. I purchased it. We have not done it. Everything is purchased. Once the product is there, then I will start. Because only 4 motors and jets are required. Yeah, it is. Because the blades and all are not costly. Only the 4 jet propellants are required. That's all. Yeah. Yeah, sure. That's what I am also planning for my startup. Thank you. No, for her. She has done it. It's not me. I hope the next batch will take over from that. Oh, thank you.
The accuracy of 99%. You can see the predictions there.
So when the camera is kept to the plant, I think I'll rotate the table so that you can see the. So we are keeping it to, sorry, this one. So we are keeping the camera to the plant directly. So you can see the predictions and the plant disease and all these things. So you have bacterial blight, blast, brown spot, tongue. So we have restricted our diseases to 4 varieties, and we are trying to analyze whether it is there or not. So the predictions are something like the classification took so many milliseconds, and the DSP has taken 7 milliseconds, and the accuracy is coming to anomaly is 0. Yeah.
So it depends on the brightness also.
Yeah, plant. Yeah, we can give image and we can see it also. Yeah, we are already tested with the data set what we have 80% data, we took it as test data, 20% we are running on that and seeing it.
So the accuracy that you're talking about, like 95%, that is with the still images or with
No, live also. These are all like pictures we captured by mobile and we brought it and we are giving it to the CNN and seeing the outcome of it.
So the accuracy does not vary
It will not vary. It is almost this test set is same.
because in the video I'm seeing like there are some image quality is dropping.
Yeah, that is true. What you have told is true. It depends on the image quality also. It is not that blurry image you will get. If the image is good, the classification will. If the image is, it will not be there.
Like the still images are good, but live video the quality.
Yeah, it can be because we are live on the plant and we captured some from on the mobile. We have faded it and when the product is ready, go along and see it will be different. Right. So this is first step project. If it is give us some money, then we will with other product. Yeah. We also have monitoring station what for agriculture. If you go to agriculture to research, they do is they have some tanks and they put the crop and there is the environment, nitrogen, phosphorus, potassium parameters they and see how the growth is. So they always what they are trying to do, going there and testing how this happens. We built a station where they go to the field, they can sit in the office and see the tanks, what are the percentages they have, and they automatically open the jet for whatever it is. Like nitrogen is reduced, they increase it. So what they are trying to do is phosphorus, they give 20%, 40%, 60%, 80%, and see how the growths are and all. So for that, we developed a monitoring station where they can completely see the data on the monitors. Yeah. Okay, thank you all.